What's up, Geometry Honors family? Well, guess what? We're at the end of chapter 10. Woohoo! And today, we're not going to be focusing on angles and vertexes and their locations. We're not going to be focusing on the segments, the chords, the secants, the tangents. We're actually going to give a party for the circles themselves. We're going to be checking out their arc lengths, their circumferences. It's all about the circle today. Ready, you guys? It's pretty cool. All right, check out this cute little girl. So there's a merry-go-round. It has a diameter of 25 feet. So let's just pretend this is my merry-go-round. Here's my diameter. It's 25 feet. Okay, if this cutie patootie kid spins it 3 revolutions, how far, what's the distance they would have traveled? My question to you is not so much find the answer to this right now, but when you think about this, what formula will you need? What will you need? We'll need the circumference, and then once we find that, we multiply it by 3, and we figured out the distance this poor sweetie traveled on it. And so what we'll need is the circumference, which is 2 pi r, and another way to write that is pi times d, where d is the diameter. And then, in this situation, they're going to want us to multiply 3 times our circumference to figure out what she did, which is 3 times 25 pi. So she traveled 75 pi. That's the distance that she traveled on, this guy. All right, let's take it back to the basics right now. If the circumference of a mirror is 88 millimeters, they're asking me to find the radius. Well, I know the circumference formula is 2 pi r, and I'm not using pi times d, the diameter, in this situation because they're asking me to deal with the radius. And so it's telling me that 2 pi r here equals 88 millimeters. And I want to solve for r, so let me divide both sides by 2 pi. And I have 44 over pi millimeters is what they're looking for, which is my radius. Next one, if the circumference is 24 pi, find the radius of the circle. So again, circumference is 2 pi r. They're telling me it's 24 pi. And the way to solve for the radius is divide both sides by 2 pi. And I have 12. All right. Another thought. If the radius of the circle below is 12 centimeters, so here's my radius, what is the circumference of the circle in terms of pi? What is the circumference of the circle? I'm not asking you to tell me it's 360 degrees. I want the actual measurement. Again, circumference equals 2 pi r, and I'm using r in this situation because they've given me r, and I have 2 pi times 12, and so I have 24 pi is the circumference of my circle. Okay, let's get a little bit more specific here. In the previous slide, I asked you guys to find the entire circumference of the circle that had radius 12, and we found that entire circumference. Okay, let's say I don't want to know the entire circumference. I just want to know this right here in red. So the whole thing we figured out in the previous slide was 24 pi. I don't want to know 24 pi. I only want to know what's in red. And so the way that I would do that is I would find that proportion. It was 120 degrees out of 360. The whole thing was 24 pi. So I'm going to multiply my proportion by the whole thing, and I'm going to be left with 8 pi. In other words, what's in red is 8 pi. The whole thing from the previous slide was 24 pi. And so if we generalize it down below, we could come up with something like the measure of an arc divided by 360, which is the degrees of the entire circle, times 2 pi r, would give us our arc length. Now 2 pi r gives us the entire circumference, but if we're just asking for a small section of that circumference, we take the measure of the arc length divided by 360 and multiply it by the entire circumference. You guys, the formula that just popped up on our screen right here didn't transfer to my iPad appropriately, it looks like. So take a look at what you have written in your notes. Don't look at this wackadoodle thing. It didn't transfer, the script didn't transfer correctly. I apologize for that. But in your notes, it says that A, the arc length, equals theta, which is the degrees of your central angle, divided by 360, times your circumference, which is 2 pi r, is how you find your arc length. In other words, you take your proportion, 120 degrees in this situation, we divided it by the whole thing, which is 360 degrees, and then we multiplied it by our circumference. That's how we found that arc length. Again, forget about this wackadoodle thing and just look down at your notes, and I'll try and fix this slide for future lessons. Oh my goodness, another correction here. Measure of angle RPM is not 50 with a little mini zero, it's 50 degrees, just like it is in your notes. I don't know what happened with this transfer here. It's 50 degrees. Okay, let's get back to example 1. In circle P, it says MN, which is the diameter, is 8, so I'm already going to cut that up into 2 radii, 4 and 4. And measure of angle RPN is 50 degrees, just like the way it says in your printed notes. So over here I've got 50 degrees. Find the length of arc QMR. So we are looking for QMR, not the circumference of the entire circle, but that portion of it over there. All right, so what do I know? I have a semicircle over here, which will add up to 180 degrees, which means if angle RPN is 50, then angle RPM would be what? 130. I'm so glad you answered that question. And I also know that this is 90 degrees here. Okay, so if I'm going to take a look at this angle here that is opening up to the arc that they're asking me for, I will have 130 plus 90, which will give me 220. Again, that angle I highlighted in blue is the angle that is opening up to the arc that we're looking for. And so the way I find it is I take my theta, which is the degrees of my central angle that's opening up to the arc, divide it by 360, there's my proportion, and I multiply it by the circumference. The circumference here is 2 pi r, which would be 8 pi. Okay, and so once I simplify that, I have 44 over 9 pi, and that is my arc length. Ooh, look at this one. Find the complete perimeter of the figure. Leave your answers in terms of pi and whole numbers. So far, all I know is that this segment here is 3 and this is 3. I still need to find this, and I need to find the length of this. Then I'll have my complete figure. Okay, let's look at that inner circle. I'm going to call it the small circle. The small circle, let's find the circumference, and I know the circumference is pi times diameter, and I'm leaving it diameter now because I know the diameter. The diameter is 4, so I'm going to have 4 pi. Now, I'm going to divide it by 2 because they're not asking me for an entire circle, they're asking me for half of it, correct? And so my answer is going to be 2 pi. So that length, and I'll make it in red here, this is 2 pi. So I have 2 pi, I have 3, I have 3. Now let's find that outer circumference. And so now for the large circle, and I'll here write large circle, the circumference is going to be also pi times the diameter. The diameter here is what? It's 3 plus 4, which is 7, plus 3, which is 10. So I'm going to say 10 pi is the circumference of this entire circle. I don't want the entire circle though, so I'm going to divide it by 2, and I'm going to have 5 pi. Okay, let's look back at what they're asking me for. Find the complete perimeter of this figure. So I'm going to have 2 pi plus 5 pi plus 3 plus 3. And when I simplify that, I have 7 pi plus 6. And they've asked me to leave it in terms of pi and whole numbers. Voila! Your homework is on the following slide. Great job, Harriton.